Learn like a pro.
All right, team, welcome. I'm the Senior Process Engineer here, and I'll be your guide today. We're about to follow one of the most versatile molecules in our entire operation, from its kind of violent birth all the way to its final form in things you use every single day. So, let's jump right in.
So let me kick things off with a question for you. A clear, rigid plastic bottle and a soft, spreadable tub of margarine. On the surface, they have absolutely nothing in common, right? But chemically, their stories are, you won't believe it, deeply connected. And the hero of both those stories is the exact same tiny reactive molecule. So, a huge welcome to all of you. Today, you're getting the full behind-the-scenes tour, and we're going to focus on the real star of our show, the alkene. This little guy is the starting point for so many things we all rely on, from fuels to detergents, and we're about to see exactly how it all happens.
Okay, first things first, the fundamentals. An alkene is what we call an unsaturated hydrocarbon. Now that word unsaturated, that's everything. It basically means the molecule isn't full. It has at least one carbon-carbon double bond, and you can think of this bond as a door that's just waiting to swing open and let new atoms come inside. That's what makes it so reactive and so incredibly valuable to us.
Here's a really simple way to picture it. A saturated molecule, something like an alkane, is like a completely full parking lot. Every single spot is taken. There's no room for anyone else. But an unsaturated alkene, that's a parking lot with empty spaces, that double bond. It's practically begging for other molecules to come and park, which, as you'll see, is exactly what we're going to make it do.
All right, first stop on our tour, the cracker. You can't use alkenes until you actually make them. And believe me, they don't just exist in huge quantities out in nature. We have to literally create them from bigger, much less useful molecules. This is where it all begins.
You know, cracking is the perfect name for it. We take these long, heavy alkane chains, the stuff you find in crude oil that isn't really great for much else, and we basically smash them apart. Inside the cracker, we use brutal heat. We're talking around 600 degrees Celsius, and a catalyst like aluminum oxide. The heat gives the energy, and the catalyst gives a surface that helps these big, clumsy molecules break down into a mix of smaller, way more valuable products, including our star, the alkenes.
So what you're seeing here is the basic idea, like a lab setup. Now, I want you to imagine this scaled up to the size of a building, processing thousands of barrels of oil every single day. That's what's happening right here in this plant. It's a totally vital industrial process that turns low-value gunk from crude oil into high-demand gasoline and the essential building blocks for the entire plastics industry.
Okay, so we've successfully cracked our feedstock, and we've separated out our alkenes. Now let's zoom in and get a closer look at the one chemical feature that makes them so special. This is their secret weapon.
This right here is ethene. It's the simplest alkene you can get. And there, right in the middle, that's it, the carbon-carbon double bond. Now, unlike a sturdy single bond, one of the connections in this double bond is actually pretty easy to break open. This is the heart of an alkene's reactivity. It's the open for business sign on the molecule.
So how do we prove that double bond is really there and, ready to react? Well, we use this really cool visual test. We take our gas and bubble it through bromine water, which has this very distinct brown color. Now watch what happens. That double bond on the alkene just breaks right open, and the bromine atoms add themselves to the carbon chain.
And this just shows the difference perfectly. With an alkene, that brown color completely vanishes because the bromine gets used up in the reaction. It's a crystal clear, positive test for an unsaturated molecule. Now, if we tried the same thing with a saturated alkane, absolutely nothing would happen. The water would just stay brown. So this simple color change is how we know for sure we've got what we need to move on to the next stage.
All right, team, follow me. Now that we have our super reactive ethene, we're going to put it to work. Our next stop is the polymerization unit. This is where we take these tiny little individual molecules and build them into something much, much bigger and a whole lot stronger.
The process is called polymerization. Think of it like this. Our little ethene molecules, we call those monomers, are like individual paper clips. Polymerization is the process of linking thousands, sometimes even millions of these paper clips together to form one incredibly long chain, and that chain is the polymer.
So how do we do it? We take our ethene monomers and we hit them with high temperature and high pressure, along with another special catalyst. Under these conditions, that reactive double bond in each and every ethene molecule breaks open and they just start linking up end to end, forming this massive chain molecule called polyethylene, which I guarantee you know as polyethylene, the most common plastic in the world.
From plastic bags to margarine. Yep, you heard that right. For our final stop, we're going to see how the exact same chemical principle, opening up that double bond, is used to turn a liquid vegetable oil into a solid spread. It's an absolutely fantastic example of controlling chemistry to get a physical property you want.
Now check this out, because this is the key. Look at the effect that double bond has on the molecule's shape. On the left, in liquid oils, the unsaturated chains have these bends or kinks in them wherever a double bond exists. But on the right, in solid fats, the saturated chains are perfectly straight. This tiny difference in shape is everything.
So because those bent, unsaturated chains in oil can't pack together tightly, the forces between them are pretty weak. That's why oil is a liquid at room temperature. But the straight, saturated chains in fat, they can stack together really neatly, kind of like a pile of logs. This lets stronger forces develop between them, which gives them a higher melting point and makes them solid.
So to make margarine, we use a process called hydrogenation. We take polyunsaturated vegetable oil, we heat it up with hydrogen gas, and we use a finely divided nickel catalyst. What happens is the hydrogen atoms add themselves across those double bonds. This breaks the double bonds, straightens out those kinks in the chains, and turns the liquid oil into a semi-solid fat. We can actually control the process to get the exact texture we want.
Now, a quick but really important note on quality control. This process has to be managed super carefully. If it's only partial, or if some side reactions happen, it can create something called trans fats. And these are basically unsaturated fats with an unnatural shape that have been linked to health problems. So precision in our process is absolutely critical.
And that brings us to the end of our tour. We've followed the alkene all the way from its creation in the cracker to its final transformation into two wildly different products you can buy in a store. It's a pretty remarkable journey for such a simple-looking molecule, isn't it?
So let's do a quick recap of what we saw. We started by cracking big, clunky alkanes to produce our useful alkenes. We proved how reactive they are with the bromine water test. Then we put that reactivity to good use, first with addition polymerization to make plastic, and then with hydrogenation to make margarine from oils. All of that thanks to one special little bond.
I'll leave you with this final thought. From the container holding your lunch, to the detergents under your sink, even to the fuel in cars, the hidden world of alkenes is literally all around you. Now that you know their secrets, I challenge you to see just how many of their products you can spot in your daily life. Thanks for your attention, team. Great having you.